Okay, so let's have this problem. So find the standard equation of an ellipse with vertices -2, 3 and -2, -7, and the eccentricity is 3 over 5. So first we need to graph the given, so using the given coordinates. So we have the coordinates of the vertices. So first we have the -2, 3. So first vertex, then the second one, that's -2 and -7. So looking for our graph, so compared to our table, so observe that the position of our vertices is in vertical position. So therefore we're going to use this formula, the x over the b squared formula. So this is the formula we're going to use to solve this problem. So take note that a is the half of the distance of the vertices, and then b half the distance of the endpoints, c is half the distance of the foci. So first thing to do is to solve the center using the coordinates of the vertices, because the midpoint of our vertices is the center of our ellipse. So using the midpoint formula, so the x sub 1 plus x sub 2, then y sub 1 plus y sub 2, and these are the values. So x sub 1, y sub 1, x sub 2, and y sub 2. So you just have to substitute this number on our formula. So we have x sub 1 plus x sub 2, so -2 plus -2. Then for y sub 1, that's 3, and y sub 2 is -7. Then you simplify, so -2 plus -2, that's -4. Then 3 plus -7, that's -4. Then you reduce this one, so that's -2, -2. So this is the coordinates of our center, so -2 and -2. So next, since we have the given vertices and half the distance of vertices is a, so we need to compute the distance between the two vertex. So we have two methods to do that. So using the distance formula or the counting method. So now I'm going to use the counting method. So this is how to do counting method. So you start counting on the next point. So we have this one, 1, 2, 3, 4. So again, start counting on the next point. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So therefore the distance between the two vertex is 10, and half of that is a, so divide by 2. So 10 divided by 2, that's 5. Then we have another given, the eccentricity, that's 3 over 5, and formula for eccentricity in a vertex, in an ellipse. So E that's equals to c over a. So since eccentricity is 3 over 5, so that's equals to c. So c is unknown and a is 5. So from this equation, so therefore c is equals to 3. So 3 over 5 is equals to c over 5. So c is equals to 3. Now from this value, so center is -2, -2, a is 5, and c is 3. So we can solve now our b. So solving for b using this formula, so a squared minus c squared, where a squared is 5, then c squared is c is 3. Then you simplify, so 5 squared is 25, 3 squared is 9. Then you subtract, so the square root of 16, and the square root of 16 is 4. So using these computed values, we can solve now our equation. So using this formula, so you just have to substitute all the values to this formula. So we have x minus h, so x minus h, so h is -2, k is 2, so from the center, so we have x minus -2. Okay, then simplify, so this one is b, this one is a. So this one, -2, -2, so double negative, that's positive. This one, still double negative, it's positive. Then 4 squared, that's 16. Then 5 squared is 25, and this is our equation.